Single responsibility. Every class in your system should have one responsibility and one responsibility only. Problem is, what's the nature of that responsibility? There's a common mistake that new programmers often make, and we're going to explore that here, and we're going to explore the resolution to it too. Let's have a look at giraffe. So giraffe was one of your objects in the system. It represents a real world object, obviously, a giraffe. The data for it comes from the database. And the question to ask is, what's the responsibility of a giraffe? You could argue that the responsibility of a giraffe is to implement everything in the system, everything you could possibly need in the system, and all of the data that could ever be associated with a giraffe. And if you would argue that, then you'd be wrong. That's not what it is. The important thing about a giraffe, and in fact any object in your system, is that it's for the purpose of properties and methods that only affect that object. So in this case, that only affect a giraffe, and the only is very important. In the case of a giraffe, which is an entity that, as I say, comes from the database, what's the nature of that going to be, really? I mean, what are you going to be storing here? Well, it's data. It's basically a data store for your entity. So it's going to store things like date of birth, the giraffe's name, the giraffe's weight at admission, maybe its current weight, this kind of thing. Only data. That's the single responsibility. So if you start putting a lot of processing in your entity object here, you've broken the single responsibility principle. Because these kinds of objects, these entity objects, you can almost imagine them in your head as not being giraffe or hippopotamus or whatever, rather being giraffe data, hippopotamus data. Data is the single responsibility there. So if they just store data, what about when you want to do stuff in your system? What if you want to process things in your system, like an animal admission? When an animal comes to the zoo, we need to admit it, and there's various things that we need to store and various things that we need to record at that point in time. So we have an animal admission service. When we're processing things, we call them service or processor or controller, or in this case, more exceptionally, logger for a vet visit here. They're all nouns. They're nouns by convention, and that's quite important because it'll become clearer later on how we use these services and processors and so on. Naming them as a noun makes it much clearer. And all we do with these is we split them up according to what we need in the system. Animal admission service, and that incorporates properties and methods that are only to do with animal admission service. The vet visit logger incorporates properties and methods that are only to do with vet visit. So what about if something happens where we need to incorporate both of these? How about we say, as a business rule, maybe when an animal is admitted to the zoo, we also need a visit to the vet. Well, in that case, we use a separate object again, which will be some kind of coordinator, the calling class, a controller. Who knows what you might choose to call it? You might just call it a service that would coordinate the two of these separate objects. And that will be the single responsibility of that object. So split it up according to a single responsibility. And remember, your entity object's responsibility is always just data. That is single responsibility, and it's important to use because it's not only about keeping your system intellectually manageable by splitting it up. If you're from a procedural programming background, you might make the mistake of thinking that's all it is. So it doesn't matter how you split it up. Well, that's not true, as we've seen. It also makes it easier to engineer. It makes the other solid principles possible. If you don't split up your system into objects like this, the other solid principles, you're not going to be able to use them. You're not going to be able to apply design patterns in future either, which of course is a slightly more advanced subject. And you're not going to be able to apply the principles that are generally considered to be good practice in object-oriented systems. So this is the basis on which everything else is going to build. And it's with that in mind, let's go on to the next principle, which is the open-closed principle.